Last time we started section, what did I call it, 3.8, radical equations. And we had done through, looks like example 9. Okay, so example 9 is where we stopped. I have a few more examples left, and they're all a little different than the ones we were doing last time. In particular, you'll notice what about these two examples on this page? You see a 4, right? I don't have square roots, I have fourth roots here. So, if I undo a square root by squaring, how would I undo a fourth root? Fourthing, right? It's not really a word, but yeah. I would raise it to a power of 4, right? Exactly, you guys got it. So, that's what we're going to do. We're going to raise to a power of 4 on both sides. So, on the left-hand side, the fourth root of x to the fourth is x. That's kind of the whole point. What is 3 to the power 4? It's 81. Okay? All good? How is 11 different than 10? There's a negative on the right-hand side. Any idea how that makes it different? Okay, it would be the same answer if we raise it to the power 4. You're right, because we would have -3 times -3 times, it would be 81. But what happens when I try to take the fourth root of 81? Jonah just said it. What did you say? What happens here? You're right. It's no solution, because the fourth root of 81 is 3. It is not -3. So even though if I tried to do it with the same method, and I arrived at a potential answer of 81, that answer won't work, right? I mean, it's not true, because the fourth root of 81 is 3. It's not -3. So at the very beginning, if you recognize that, here, I didn't mean to do that, to do this, you can do exactly what Jonah just said. It's no solution, and you can say it from the beginning. But you have to be paying attention for those, because otherwise it's real easy to just get in the habit of doing the same thing over and over again, and you just automatically power 4, and you move on, and you end up with something that doesn't actually work.
Is it no solution every time there's a negative?
It's a good question, because on example 12, what's different? It's a cube root instead of a power of 4. So Karen, to answer your question, when I have even indexes, I cannot get a negative. But when I have odd indexes, I can. So if I were to do this problem, again, I didn't do that before, but you know what I'm going to raise it to, right? It's the power of 3. I'd have x on the left, and then on the right I'd have -3 times -3 times -3, which gives me a what? A -27. So the interesting thing with odd powers is that you can still get negatives because you're multiplying them an odd number of times, and that can't happen when you use even powers. So over here, even indexes, if I took a 6th root, I can't get a negative. If I took an 8th root, I can't get a negative. But if I did a 5th root, I could. If I did a 7th root, I could. So it's an even versus an odd issue. Even indexes, I can have negative. I can't have negatives, but odd indexes I can. Does that make sense for everyone? Okay. Number 13 actually looks very much like when we did last time. Let me see what number it was. It was number 6. Number 6 I did last time looked like this. I had a square root on both sides, and I had items underneath the radical, right? And I do here as well. So what do you think I'm going to do to this equation? Yeah, power of 4 on both sides, exactly. And that will get rid of my radicals. So I have 4u minus 5 equals 2u plus 1. And then what? Combine like terms, right? So you might want to move the 2u first. that's 2u minus 5 equals 1. Then we'd add a 5, right? So 2u equals 6. So what was u going to equal? 3. And just for the sake of reminding you how we check these, let's do a check step. Because the reality is, you can always know whether you got the right answer or not when you check your algebra going backwards with solving equations. Whatever answer you got, you plug it back in. So if I take the 4th root of 4 times 3 minus 5, and I want to know, does in fact that equal the 4th root of 2 times 3 plus 1. So 4 times 3 would be, y'all know, 12, thank you. 12 minus 5 is 7, so I have the 4th root of 7 on the left. On the right-hand side, I have 2 times 3, 6 plus 1 is, so I have the 4th root of 7 on the right, and those are in fact equal, so we got the right solution. Okay, you can check every solution if that is something that you want to make sure of, or maybe you don't want to on your homework because there's a lot of problems, but maybe you want to on the test, just to make sure you're getting the right pieces at the end. Any questions on any of those? All right.